Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition. We're doing problem number 3.14. This problem is just a bunch of unit conversions to kind of help you understand how you can work with units and see how you can convert between different meanings, moles, relating moles and mass and things like that. But there's not a lot of preamble to it. It's just asking you to do unit conversions and things. So, how many of the following are found in 15 kilomoles of benzene? Okay, so 3.14, we're working with 15 kilomoles of benzene. Okay, and we need to know part A. How many kilograms is that? Okay, so we have 15 kilomoles, and we need to multiply that by the molar mass. The molar mass of benzene is equal to 78.11. So 78.11, that's kilograms per kilomole, or 78.11 grams per mole. So however you want to relate that. Anyway, this equals 1.2 times 10 to the 3 kilograms. Okay. Part B, we're working in moles. So if we have 15 kilomoles, 15,000 moles, or 1.5 times 10 to the 4 moles. Okay. Part C, pound moles. Okay, so if we have 15 kilomoles, then we have 1 pound mole is equal to 0.454 kilomoles. Okay, and this equals 33 pound moles. There we go. Part D, we're doing gram moles. Oh, gram atom C. No, moles. Okay, so we're doing moles, but it's grams, and it's an atom. So we're just doing it of carbon. I think that it's asking for, because all it says is mole in parentheses, G atom, close parenthesis, C. So I'm going to assume that means carbon, and we're just doing moles of carbon, and it's on the gram basis. It's not a kilogram or a kilomole. Okay. So if we have 15 kilomoles of benzene, that's a B, benzene. In benzene, in 1 mole of benzene, there's 6 moles of carbon. And we already know that in 1 kilomole, there's 1,000 moles. And those are both benzenes. Okay, so then we're just left with 9.0 times 10 to the 4 moles of carbon. Now, if I'm not 100% sure if it's asking like the number of atoms. I don't think it is, but if it was asking the number of atoms, then you would also multiply this molar amount by Avogadro's number. So I don't know if that's what it's asking for. I don't because it's a little ambiguous, but since it says moles there, we're just going to leave it as is and say these are the moles of carbon we have in 15 kilomoles of benzene. Okay. Part E, we're doing the same thing, but we're doing it with hydrogen. Okay, 15 kilomoles of benzene. It's the same thing. Equals moles of hydrogen per 1 mole of benzene. And we've got 10 to the 3 moles of benzene per 1 kilomole of benzene. Okay. And so this equals the same thing. Okay. Part F. Well, now it's asking us to convert into grams. So carbon weighs more, or carbon has more mass than hydrogen. But let's just start off with 9. 9.0 times 10 to the 4 mole carbon. The molar mass of carbon is 12 grams per mole. And so that equals 1.1 times 10 to the 6 grams. Okay, and that's grams of carbon. Okay. Hydrogen, grams of hydrogen, you start off with the same number of moles, but the moles of hydrogen has less mass, so it's only 1.001 grams per mole for the molar mass of hydrogen. So that equals 9.04 grams of hydrogen. Hydrogen weighs quite a bit less. There you go. Part H, we want to know how many molecules. Okay, here we go. This is what I was talking about with Avogadro's number. So molecules of C6H6. Okay, so if we have 1.5 times 10 to the 4 moles of benzene, then it says how many molecules of benzene is that? Well, you have to use Avogadro's number. So Avogadro's number is 6.022 times 10 to the 23, and that's molecules of benzene per mole of benzene. Okay. And this is 9.0 times 10 to the 27 molecules of benzene. Great. Okay, so that is it for problem number 3.14. If you have any questions about how to do these unit conversions, or any other questions relevant to the material, just go ahead and put them in the comments, and we can start a discussion about how to do these things, or if you have any other questions about other problems in this book, and we can start a discussion there and perhaps turn it into a video. So anyway, thank you for joining me on this video, and I hope to see you in the next one. Thanks.